In this last hyperbola example, we're going to use some given information to find both the equation and the graph of the hyperbola. In this case, we're given two foci at -7, -1, and at 3, -1, and a vertex that's at 1, -1. Now, using that information, I can find both the C and A values and the center, and then I can use that to get the B value, the oblique asymptotes, and the graph ultimately, okay? So the first thing, when I look at this, I want to find the center. Got to start from the center because everything really stems from that, right? Your A values and your B values and your C values all come off that center point. So the first thing I'll do is find the center, and I know that my foci are symmetrical about the center, right? In this case, they're at -7, -1, and 3, -1. They're both at -1 height, but it's the -7 and the 3 that are different, and so I need the average of those two numbers to get my center. So to find the center, I'm going to take -7 plus 3 and average them, divide them by 2. That sum is -4 over 2 is -2. So my center has an x coordinate at -2 and a y coordinate that's the same right there. It's -1. Okay, so my coordinates for the center, -2, -1. Now from here, that tells me that can tell me the C value, right? So the C, little c, is equal to the distance between the center and the foci. All right, now I can use either foci for this, so -2 to -7 or -2 to 3. It doesn't matter, I'll get the same value, and in this case it is 5, right? You subtract them, it'd be 3 minus -2, or you can do -7 minus -2. Either way, you're going to get plus or minus 5 out of that. And so the 5 is what we're looking for, okay? So that's my value for C, is the 5. The vertex then is how we find the value for A. The vertex is also at the same y value of -1. That's going to be our transverse axis. The positive 1 will help me to find the distance, or the A value. So the distance from 1 to -2, 1 minus -2, is going to be 3, right? 1 plus 2. So 3 is my A value, 5 is my C value. From that, I can get the value for B. We know that B squared equals C squared minus A squared. And so when I plug those in, I get 25 minus 9, which of course is 16. And that tells me that B must be equal to 4. Okay, B squared is 16, B is 4. Okay, now I have enough actually. Right at this point, I can create the equation for this hyperbola. The first thing that's really important is to know that my transverse axis is at -1, right? That's my x value, or my y value that's fixed. So I'll write that down. Transverse axis is at y equals -1. And so that tells me that this graph opens horizontally, which puts the positive on the x squared term and the negative with the y squared term, okay? So, so I can build my equation. It's going to be x minus h squared over a squared minus y minus k squared over b squared equals 1. All right, that gets me the structure of my equation. And then I just plug in the known values of a, b, h, and k. All right, so this is going to become x plus 1, right? Change the sign, double negative. The a value, a is 3, so a squared is 9. Here I get y minus, now k is going to be -2, so it's actually y plus 2, change the sign. And b squared I know to be 16. And that should equal 1, all right? So there's my equation. I have that part done. Now I still want to draw the graph of this thing. And the graph is going to require that I know a couple other pieces of information. First of all, I could get the conjugate axis out of this. The conjugate axis is going to be a vertical vertical line going through -2. So that would be x equals -2. What else do I need? I got my two foci. Oh, I need my other vertex, right? So V1 is going to be found by starting at the center, and since V2, I would add 3 to the x value to give V2. I need to subtract 3 to give V1. So I'd want -2 minus 3 gives me a -5. So that's at -5 comma -1. That's the other vertex. So my center, I've got both vertices, I've got both foci, I've got both of my axes. What I don't have are the oblique asymptotes. And so the oblique asymptotes can be found. We are going to have some shifting going on. And so the general formula is y minus k. I don't really need the parentheses around that. Equals plus or minus. Now I need the y value over the x. So it's b over a times x minus h. Okay. And so then I plug in again the b, the a, the x, and the h. Or I'm sorry, the b, the a, and the k and the h. And so I get y minus -1 is +1. Plus or minus, now b over a is 4 over 3, 4/3. And I get x minus the h, which is -2, so it's x plus 2. Again, that's going to give me two different lines, one with a plus, one with a minus. I better solve those individually. This is going to get a little bit messy because of that fraction isn't really going to simplify, but that's okay, we'll do it anyway. So we get y plus 1 equals 4/3 times x plus 2. I'll solve that one before I write the other one down. Y plus 1 is 4/3 x plus 8/3. And if I subtract the 1 from both sides, I'm really subtracting 3/3. So it's 8/3 minus 3/3 is 5/3. So it'll be y equals 4/3 x plus 5/3, right? 8/3 minus 3/3 is 5/3. The other one, same idea. If I do y plus 1 equals -4/3 times x plus 2, I distribute. I get y plus 1 equals -4/3 x minus 8/3. And then I'm going to subtract the 1, which is another 3/3 from both sides. And that gives us y equals -4/3 x. So -8 minus 3/3 is going to be -11/3. So minus 11/3. So those are my two oblique asymptotes. And I can plot all this stuff. Now all I have left to do is graph it. It is going to be horizontal. It's at -1, so -2, -1. Okay. Let's see. Let's give myself a decent sized scale here to draw this in. 1, 2, 3, 4, 5, 6, 7. Oh, let's see. I'm not going to need much past -5 here, do I? Or do I? Well, my focus is at -7, so I'm going to have to go at least that far. Let's go -8. That'll work. And then I need to go out at least to 3 in the other direction. So 1, 2, 3. We'll go 5. I got enough space for that. That should work. And then vertically, oh, I don't know, from -2, -1, I need to be able to go, let's see, 3 in each, no, 4 in each direction vertically. So, oh boy, I need a little more space there. Alright, so at -1, I need to go up 4. So 1, 2, 3, 4. Let's go up another one. 5. Okay, well that's 4 up. Positive 4 in the y, and then we got to go down 1, 2, 3, 4, 5. Let's go another one, 6. Alright, something like that. Anyway, maybe I drew those too big. I don't know. Let's get our center in there at -2, -1. And let's get our vertices in -5, -1. And the other vertex is at 1, -1. And really I should probably just draw in that transverse axis just so I can keep everything lined up. Okay, so here's some points. That's, what's this one? V1, C, and V2. My foci, they're at -7, -1. So there's F1 and 3, -1. It's way out here. That's F2. And then I just need my box. The box goes, let's see, it's 4 in the y direction, so I need to go up 4. 1, 2, 3, 4. That'll be up to 3. Maybe I'll even do the box in a different color to distinguish it from my transverse axis there. Is that sloping down? That looks like it's sloping funny. I can't tell on the screen. Maybe it's not that bad. Close enough. And then I need to go 4 down, which puts me at -5. So 1, 2, 3, 4, 5 right there. Oh, really wavy there. I don't know. Close enough. And then, you don't need the arrows. Then the box from the center going horizontally, I need to go 3 units horizontally, right? So 1, 2, 3, that puts me right on these vertices. It's kind of nice. All right. And then I'm going to erase the rest of those boxes, those horizontal lines that I don't really need. All right, so there's the box or the rectangle, and then I draw the diagonals. So yeah, I probably should have zoomed out a little bit, right? That's okay. And let's see, let's go this direction. And that way there, all right. And so there's my oblique asymptotes. I'll switch back to the green marker to actually plot the, to actually plot the hyperbola. It's going to start at these vertices and then just be asymptotic to those lines. So sort of like that. And that. And then this one that way and that way. Not too bad. All right. All right, pretty cool. Anyway, that's how we get our hyperbola. Get the box in there, get all the points in there, and that should work. Pretty cool graph. Also, just to check that these asymptotes are accurate, let's see, the one with the positive slope should be a 4/3 slope. So if I go up 1, 2, 3, 4 and over 1, 2, 3, I get the point on the graph, so that's good. 5/3 should be the intercept. That's what 1 2/3. That looks pretty close to 1 2/3, I think. And then this one is a negative 4/3 slope, so you go down 1 2 3 4 and over 1 2 3. So that works. And then it's a negative 11/3. That is a negative 3 2/3. If I go 1 2 3 and well 2/3 1/3, what is that? Yeah, 2/3 should be. Maybe that's off a smidge, but it should maybe be a touch lower. But it's not too bad for what I've got drawn up here. So doing that freehand. Okay. So anyway, that just gives you verification that I had all that in there correct. Again, all the points are good, so looks good. That should do it for our hyperbolas.